Welcome to InCabin from the creators of AutoSens. InCabin connects the global community of automotive interior specialists working on in-cabin safety, comfort, and productivity solutions through industry-leading events and knowledge sharing. We are pleased to welcome to InCabin today Karsten Krispin, CEO of rabbitAI. And Karsten, welcome to InCabin. Good to see you, friend.
Hi, welcome. And I'm very happy to be here.
Karsten, your training data has been called game-changing. So what exactly causes this game-changing effect with your training data?
So from our perspective, when it comes to training data, especially computer vision, I think there's this clear dichotomy between real-world data and synthetic data. And I have the impression there is a kind of fight going on, what is the best of both. And from our perspective, we don't see this dichotomy because we believe there is no real or synth. It's both the same. You can be entirely realistic by synthetic data, but you have to put a lot of effort into modeling it. And sometimes the modeling effort is way too large to do it. And on the other hand, you have real-world data that is captured by cameras. And that means this data is really realistic in that sense. But we also have to see that, putting images from a camera and using it does also mean you put it into a matrix. It's a mathematical object. So that also means it's kind of synthetic. So it's not real. The question is, what is real? And from our perspective, this is really the crucial part. So we want to get rid of this dichotomy by basically having a slider that allows to go from absolutely realistic to absolutely synthetic, just as you need to get the best data out of it. And this means that we can basically, have real-world data that behaves as synthetic data, because you can derive the same ground truth quality from it as you used from synthetic data.
Karsten, as you're explaining this, let's go a step farther. How does this approach, how does this solution benefit your customers?
So from our perspective, there are different, modalities that are easier to record, and some modalities are easier to model. So when we think about human behavior, upfront, we don't know how humans behave. Think about, impaired drivement. How do we know how drowsiness signals, or I don't know, whatever happens really relates to drowsiness or also impairment in general? We first have to measure people to understand what's going on. So this seems to be the only way to get reliable ground truth, by measuring it. On the other hand, so we have, for instance, if we need data or edge cases that test if people or the algorithm still works with, let's say, sunglasses, which occlude the eyes. Of course, it's a big signal on impairment, as an example. It's much easier to do this synthetically, because once you know the head rotation, for instance, it's easy to put synthetic objects onto the scene. And this can, for instance, be easily done with our technology, because, as I said, we record real world, we create digital models from it, and then we can alter it to some extent. So the benefit is that whatever data you need, you either take it from real world or you take it from synth. And because we have this possibility to go between, this allows to actually also use real world data much more often than you're used to right now, because currently it depends a lot on the perspective of the camera, the resolution, the camera model, the sensor model. And so that means if you really want to do rigid testing, for instance, you need to record this data all the time, again, for different systems. And this has a huge cost factor, because you need to label the data, the key points, or whatever you're doing. And with our technology, it's possible to do the same for different systems at once. So you only need to record once, have the same labeling efforts, but spread it to different systems at the same time. And you can create edge cases, so like sunglasses on top, that you don't need to record. So the clear benefit is that you get much faster to the amount of data that you need to get a successful product running, but it's scalable at the same time, because it's automated, most of it.
Karsten, when it comes to OEMs and tier one suppliers, what challenges do they face when it comes to this topic of the reliability of the training data?
So I think OEMs and tier ones or suppliers have two quite different challenges. Still, they're working on the same problem. So let me explain a bit what I mean with that. So first of all, there are suppliers like and tier ones, and they have the solution for in-cabin sensing systems. And what they need to work on and what they need to get done from this perspective is for when it comes to data, it doesn't matter too much where the data comes from. The only thing is it needs to be effective. It needs to make a working product. So if it's real or synthetic, doesn't care. Ideally, it should be as cheap as possible because you need a lot of it and you need a lot of variance in it. And but then you also have the OEM. So the OEM needs to integrate the solutions. So the OEM is interested in knowing, okay, so how good is the solution? How good and safe is it? And I would say from this perspective, and also from people who assess the safety, they are more concerned about their realism. So they trust more in real world data and to make sure that in the end, the actual system that is going to be validated really works well. And this requires another entirely different set of data variants than building the system, because validating and testing is a whole different story. So you need to make sure that you can combine both.
We're speaking today with Karsten Krispin, CEO of rabbitAI. And Karsten, can you go through a specific use case that your clients have used the rabbitAI solution for?
So the rabbitAI solution is a very good solution when it comes to the whole occupancy monitoring domain. So it's about the understanding of the whole setup and the whole things that are going on in the whole cabin at the same time. So this becomes even more important when we, for instance, deploy safety relevant systems such as airbags or seat restrainer. They all need to be parameterized very well, and they need to act or don't act depending on, for instance, if a person is sitting upright or not, because it might, damage the person even more, although it should be about safety. So when it comes to that, customers approach us to get the whole understanding of the whole scene, and we have these two perspectives again about safety. So then there is, for instance, the OEM who needs to make sure that everything is working very well. So he is going to use the same system that we supply to create training data and record training data, real-world data that is going to be accepted by safety validators, also the Euro NCAP people. And this works quite scalable. And at the same time, people who are working on the product, by doing validations, you will realize that the supplier have issues with this very specific setup. So they can use this existing real-world data then to use our going more to the synthetic side to create much more variety of setups to test if the different occupancy monitoring systems are actually working properly. So the one hand is we ensure safety by making it on real data only, and then also real data allows to be modified and derive much more training data that fine-tunes the actual systems towards the actual solution for the OEM.
Karsten, let's say that I want to record my required training data. How long will it take before I can integrate your data into my development cycle?
So I think there are a few easy steps that we are typically going through. The first thing is, of course, the requirements analysis. So you tell us what you need, what kind of precision on different modalities, like the depth or the body pose, or also body volume, and maybe also body mass. And then we need to think of also like, safety or precision in terms of how often do you expect that this is really working out. And after we have collect all these requirements, we can think about a specific setup that works for you. And so from here to the working specific setup, I think it's 2 weeks, maybe a month. And then after that, we are able to build a collection rig. So it's a reference rig that we can build, and it can be more or less readily deployed within 1 to 2 months to really be used daily if it's necessary by the customer to collect all the data it's required. And from there on, We can also derive synthetic data. So it's kind of a loop that works within weeks of iterations of new edge cases that are going to be specified. So we can make sure that the requirements or the recordings are carried out quite fast, and that also the adaptation to new data is happening very quickly. So the iteration cycles that you need in order to get to the working product are actually minimized. So we are speaking about months in total.
Karsten Krispin, CEO of rabbitAI, our guest today for InCabin. Karsten, thank you for sharing your expertise and your thought leadership. I look forward to being able to do this again sometime here in the near future. But in the meantime, thank you for being here, friend.
Yeah, thank you for having me. And I'm looking forward to meet all the people on the InCabin in Barcelona.
For more information on rabbitAI and to find out more about our upcoming events, see the links in the description. And for more in-depth interviews like this, subscribe to our YouTube channel and join the InCabin community on LinkedIn. In Detroit, on behalf of InCabin, I'm Carl Anthony.